Welcome to the volumes by revolving a disk, part 2. And well, we're not revolving a disk, but we're using the disk method. And I promised one extra problem, one that revolved around something not to the x-axis or y-axis. I wanted a vertical line. We're going to find the volume of the figure bound by y equals 3x minus 6 and x equals 2 from y equals 2 to y equals 5. I don't know if that's clear here. Y equals 5. Excuse me, no, y equals 0. I like y equals 0. By the way, I made up the problem. 0 is fine. Y equals, oh, we could do, you know what, let's keep it as 2. So now it will look more like this. I'm going to change my shape a little bit. There, that'll be 2. And so it'll look more like this, right? I believe they call this a fustum, because it doesn't have, it's like a truncated cone there. There we go. All right, so that's the one that we're going to find the volume of. All right, so we're revolving around, I don't think I put that in the question. That's what happens when you write your own question. About the line x equals 2. Sorry, this is our axis of revolution, x equals 2. So notice that the boundary as well as the line of the axis of revolution is the same thing. So that's good. We don't have a hole, so we can use the disk method. When we did the when we were looking at the the other one where we had a line of revolution that was not the x-axis, where we revolved around the line y equals 1, we went from upper to lower, right? Since we're going from we're using y's, right? We're going to go right to left. So our radius is going to be the right function, the rightmost function, minus the leftmost function. Okay, so it's top to bottom or right to left, right? And here's our, let's draw in our radius. Our radius, so symmetric here. Our radius would be here, right? So our radius is just going to be our upper function, our right function, which is the line 3x minus 6 minus our x equals 2. But before we can do any of that, we need to solve one of our functions in terms of x, because we have a vertical line, right? So we're going to integrate with respect to y. Right, so if your axis of revolution is vertical, you're integrating with respect to y. All right, so y equals 3x minus 6. We'll solve for x. We'll add 6. Y plus 6 equals 3x, and then divide by 3. 1/3 y plus 2 equals x. All right, so now we have our two functions here. 1/3 y plus 2 equals x. So our radius will be the right function, which is 1/3 y plus 2, minus our left function, which is 2. Well, that made things a little easy now, didn't it? It just worked out that way. So, probably because it's a line, we've got now 1/3 y. That's going to be our radius, right? So to find our volume, right, we're going to integrate. We need our pi because it's a disk. And we're integrating from 2 to 5 on the y there. And we have 1/3 y dy, which will be pi. It'll be, I have to divide now by raised to the second power and divide by 2. It'll be 1/6, right? Y squared from 225. I made this problem up completely, so let's see how. I mean, it matches. I mean, that's what if you did these things, that's what you'd get. You'd get that fustum shape there. Kind of actually looks like a cup. So all we have to do now is evaluate, and you'll find the volume of our. Well, it can't be a cup because it's solid. So our fustum. So we have. Oops, I don't really need the parentheses. They only have one term. So we have pi times 1/6 squared minus 1/6. And I could have pulled out the 1/6 and multiplied it right afterwards. 2 squared. So that's going to give us a little more space to write. So 5 squared would be 25 times 1/6 is 25/6. So our volume is pi times 25/6 minus, right, so that'd be 4/6. I'm going to leave it as 4/6 so I can subtract. And then I can simplify afterwards. So that's going to be 21/6, which does reduce, divisible by 3, so that would be 7/2. So our volume is 7/2 pi. How about that for our little solid fustum here? All right, so I wanted to do one with the vertical axis not being the y-axis, so you can see how that would look. I think this is a straightforward problem. And if you have any questions, just ask me in class. All right, and as a reminder, this is the closing. Kind of similar to mine. You have a line as well. I could have drawn the rest of the line in, but I didn't, because that's all I needed. All right, so f of x equal, you're going to sketch the solid obtained by revolving the region under the graph of f of x about the x-axis over the given interval. And so f of x equals x plus 1 from 0 to 3. And if you have all your steps, that will certainly suffice for your justification. All right, so see you in class. Bye.